Welcome to our electrical engineering YouTube channel. In this video, we will see an example on equivalent resistance. To download our electrical engineering app, you can visit this website link electrical-engineering.app. This app is specially designed for electrical and electronics engineering students. Question: find equivalent resistance between terminals A and B. Now here for this network, here we can see there are multiple networks here. So there are total 5 questions in this. So first we will solve this network. So let's copy this circuit from here. Now we will write problem number 1. Now here we have to determine its equivalent resistance between terminal A and B. Now here we can clearly see, let's say this is node A. Now here also and here also this is node A. Now similarly this is node B and this is also node B. Now let's draw this circuit, redraw this circuit again. So this will be A and here this is node A. So now what we can do? We have to add one resistance between A and B of 8R. So let's add this resistor here of 8R. This is B and this is also B. So this is 8R. This resistance we have added. Now next we will add this resistance 12R between terminal A and B. So let's add resistor 12R between terminal A and B. So this is 12R. This is also completed. Next we have to add this 24R. We have to add this between terminal A and B. So let's add like this. Now this is 24R. Now if we want to determine its equivalent resistance, it will be 1 upon R A B is equal to this 1 upon 12R plus 1 upon 8R then plus 1 upon 24R. Now if we want to simplify this, we can take this 1 upon R common. So 1 upon R A B will be 1 upon R in bracket 1 upon 12 plus 1 upon 8 plus 1 upon 24. So if we solve this, it will be, let's solve this directly in calculator. So it will be 1 upon 12 plus 1 upon 8 plus 1 upon 24. So it is simply 1 by 4. So this will be 1 upon R into 1 by 4. This is the value for RAB. But here we have to find the value of RAB. So therefore RAB is equal to 4R. So this is how we can find the equivalent resistance of this network. Now similarly, we will solve second problem. So second problem here is this one. So first of all, let's copy this circuit from here. Now this is our second problem. And this is the circuit diagram or network. So now again what we will do? We will take terminal A and B. So let's say this is terminal A and this is terminal B. Now what we have to do? First we will add, let's say, this resistance 4R. So let's add between terminal A and B. Here we can see this is also terminal B. This is also terminal B. this is also terminal B and this is also terminal B. So A and B, there is one resistance and that is 4R. So here we have to add 4R. So it will be 4R. Now next, again between A and B, this is 4R. So let's add again 4R. So this is also completed. Now similarly between A and B again there is 4R. So let's add here. It is 4R. And then finally this A and B, this is 4R. So it will be like this. This is 4R. Now here we can see between terminal A and B, these are all connected in parallel. So it will be like this. 1 upon RAB is equal to 1 upon 4R plus 1 upon 4R plus 1 upon 4R plus 1 upon 4R. Now from here we can take this 1 upon R common. So it will be 1 upon R in bracket 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. And this is the value for 1 upon RAB. Now if we solve this, we get 1 upon RAB is equal to 1 upon R. And this will be 1 plus 1 plus 1 plus 1. It will be 4. So 4 divided by 4. So this will be simply 1 upon R into this will be 1. Now from this we can clearly see RAB is equal to, if we take the reciprocal of this, so it will be simply R. So therefore the final answer for this problem is RAB is equal to simply R. Now next we will solve problem number 3. So here this is the network. Now let's copy this network from here. So this is problem number 3. Now here we have to take terminal A and O and B. So let's draw terminal A. This is terminal A. This is node O and this is terminal B. Now what we have to do, we have to add resistance between terminal A and O. It is R. So between A and O, it will be simply this R. Then between terminal O and B. Now here we can see this is also B, this is also B, and this is also B because they are all connected together. So between terminal O and B, it is 8R. So between O and B, it is 8R. Then this 8R is completed. Then O and B again, this is 12R. So here we have to add parallel resistance of 12R. It will be 12R. So this is also completed. Then next, between terminal O and B, there is one more resistance and that is 24R. So again we can draw here. Let's erase this O and write O here. Now this 24R is remain. So let's draw it. So now this is 24R. Now here we can clearly see this resistance is in series with these three parallel resistances. So therefore RAB is equal to, so here R, then plus, now these three are in parallel. So it will be simply 1 upon 1 by 12R, then plus 1 by 8R, then plus 1 by 24R. Now to simplify this, first we have to simplify this term. So it will be R plus 1 upon, now here we can take this R common. So what's remain? 1 by 12 plus 1 by 8 plus 1 by 24. So let's solve this. 1 by 12 plus 1 by 8, then plus 1 by 24. So this will be simply 1 by 4. That means 1 by 4 into R. So we have to take the reciprocal of this term. So it will be R plus 4R. So therefore this is the value for RAB. Here also this is RAB. So that's why finally RAB is equal to 5R. So this is the final answer for this problem number 3, and it is 5R. Now next we will solve problem number 4. We have completed problem number 3. Next is problem number 4. So first of all, let's copy this circuit from here. Now we will write problem number 4. So let's take different color. Let's say we will take this color. This is problem number 4. Now here again we will redraw this circuit to simplify it. Now here we can see this is one node and this is second node. So here also this is B, and here also it is B, and here it is A, and here also it is A. So let's draw two terminal A and B. So let's say this is terminal A and this is terminal B. Now first of all, let's add this resistance, this 10 and this 20. They are connected in series between terminal A and B. So let's add them. This is one resistance and this is second resistance. So this is 10 ohm and this is 20 ohm. So this is also completed and this is also completed. So 10 ohm plus 20 ohm. Now next, again this 20 ohm and this 10 ohm, they are connected in series. Here we can see this is the jumper. So 20 ohm and 10 ohm, they are connected in series between terminal A and B. So again let's redraw resistance 20 ohm and 10 ohm. So this is 20 ohm and this is 10 ohm. They are connected in series between terminal A and B. So these two are also completed. Then again between terminal A and B, this is 60 ohm. So again between terminal A and B, this is 60 ohm. It will be 60 ohm. Now next, this is also completed, and finally between terminal A and B, this is 60 ohm. So again between terminal A and B, one more 60 ohm resistance. So this is 60 ohm. Now we have the simple network. Now we can easily simplify this. So first of all, let's copy this circuit. Now here we can clearly see this 20 ohm and this 10 ohm, they are connected in series. Also this 10 ohm and 20 ohm are connected in series. So let's solve this first. So we can replace this by 30 ohm because 20 plus it will be simply 20 ohm plus 10 ohm is equal to 30 ohm. So let's replace this 20 ohm and 10 ohm by a single resistance of 30 ohm. So it will be simply 30 ohm. Now next again this 10 ohm and 20 ohm are connected in series. So it will be simply again 30 ohm. It will be 30 ohm. Now here we can clearly see this 30 ohm, 30 ohm, 60 ohm and 60 ohm. They are all connected in parallel. So therefore 1 upon RAB is equal to 1 upon 30 plus 1 upon 30 plus 1 upon 60 plus 1 upon 60 because they are all connected in parallel. So if we solve this, it will be 1 upon RAB is equal to, this will be simply 1 upon 30 plus 1 upon 30 plus 1 upon 60 plus 1 upon 60. So 1 upon 30 plus 1 upon 30 plus 1 upon 60 plus 1 upon 60. So it is simply 1 upon 10. 1 upon 10 is the value of 1 upon RAB. So therefore RAB is equal to simply 10 ohm. So this is how we can solve this type of problem. Now similarly, next problem we will see. So next is problem number 5. So first of all, what we can do, we can copy this circuit from here. So let's copy it simply. Now we will take different color for solving this problem. Let's say we will take white color. So this is problem number 5. Now next, to solve this problem number 5, what we can do again, let's say this is terminal A and here also this will be node A and here also this will be node A and here this is B, so this will be B and here also this will be B. Now here let's assume this node as node O for simplification. So now let's draw 3 terminals A, O and B. So let's draw here. This is terminal A, this is O and this is B. So now let's draw this resistance, let's say. So if we draw this 2 ohm, it is in between A and O. So it is in between A and O and the value of resistance is 2 ohm. So this is 2 ohm simply. Then between O and B, here this is 4 ohm. Between O and B, it is 4 ohm. Then between terminal, let's say between terminal A, or first of all let's take the internal circuit. So again between terminal A and O, this is 8 ohm. So let's take this 8 ohm between A and O. Now this is 8 ohm. So this 8 ohm is also completed. Now finally this 6 ohm between O and B. Between O and B, 6 ohm resistance. Now next, between terminal A and B, this is 3 ohm. Between A and B, between terminal A and B, this is 3 ohm simply. So it is 3 ohm. And again, between terminal A and B, this is 6 ohm. So again, between terminal A and B, this is 6 ohm. So this is 6 ohm. Now let's simplify this. So here we can see this 8 ohm and 2 ohm, they are connected in parallel. So let's solve this. 8 ohm parallel with 2 ohm. 8 ohm parallel with 2 ohm. It will be simply 8 into 2 divided by 8 plus 2. And if we solve this, we get 8 into 2 divided by 8 plus 2. So it is simply 1.6 ohm. Now similarly, this 6 ohm and 4 ohm, they are connected in parallel. So 6 ohm parallel with 4 ohm. So this will be 6 into 4 divided by 6 plus 4. So let's solve this in calculator. It will be 6 into 4 divided by 6 plus 4. It is 2.4 ohm. Now what we can do? We can redraw this circuit again. So first let's copy this circuit from here and paste it here. Now here we can replace these two resistances. 8 ohm and 2 ohm, they are connected in parallel. So 8 ohm and 2 ohm can be replaced by 1.6 ohm. And this 4 ohm and 6 ohm also can be replaced by 2.4 ohm. So it will be simply 2.4 ohm. 2.4 ohm. Now here we can see this 1.6 and 2.4, they are connected in series. So again, let's copy this circuit here. Now we can add 1.6 plus 2.4. So it will be simply 3 and 4. So it will be 4 ohm. So let's replace these two resistances by a single resistance of 4 ohm. We can erase this O now. So it will be simply 4 ohm. Now here we can clearly see these are all connected in parallel. So therefore 1 upon RAB is equal to 1 upon 4 plus 1 upon 3 plus 1 upon 6. If we solve this, we get 1 upon 4 plus 1 upon 3 plus 1 upon 6. So it will be 3 by 4, or we can say 0.75. We have to take 3 by 4. So 3 by 4, because we have to take the reciprocal then. So therefore RAB is equal to 4 by 3. And therefore RAB is equal to, we can take its unit as ohm now. So 4 by 3 is 4 divided by 3 is equal to 1.33 ohm is the final answer for RAB. So this is how we can find the equivalent resistance. If you want more practice problems, you can visit our website link electrical-engineering.app. This website or app is specially designed for electrical and electronics engineering students. Don't forget to like, share and subscribe to this channel, and thanks for watching.